Welcome back, guys. So in this video we will try to understand the stack. So in last video we have seen that how queue will work, and queue is the interface. So definitely you need to have the corresponding class which will implement your queue interface. But stack is a class. Okay, so if you look at here the hierarchy, you have a stack. A stack basically extends vector. This is the legacy class. Vector is the legacy class which is used from the edges. Vector is also synchronized. By the way, it has the same method what your array list and linked list has, because vector also will implement the list interface. So it has almost same method, okay, except then few which is specific to vector. Now this vector will implement list interface. List will extend collection interface. Collections will extend iterable. So you know that collections has few methods, iterable has few methods, and list has few methods. So this all three methods, since this interface will extend each other, is all vector has to implement. There is no other way. Vector has to implement, right? Because vector is implementing list. So indirectly vector has to implement the method of list, collections, and iterable. If not, then vector cannot implement. There should be some implementations in the vector class. And finally, vector is extended by the stack. So stack will have all the method of vector plus list plus collections plus iterable, all plus and plus 4 plus, right? So a stack will have all the methods, but we will not go into all the methods. What we have already seen that in the array list and linked list, which is all are same method, okay, there is no difference. What we will see, what extra method stack has, which is specific to a stack, that we'll try to understand. Like how a stack, when we say LIFO, last in first out, how it works, we'll try to understand. So if you look at the stack implementations, basically this stack class extends vector class. Okay, the E is the type of object which you are going to store in this class. Again, here also type of object. So stack we call it as LIFO. Stack we call it as LIFO. It extends vector with 5 operations that allows a vector to be treated as a stack. Okay, because vector has 5 operations which will help us to treat vector as a stack. The usual push and pop operations are provided, as well as the method to pick the top item on the stack, the method to test from whether the stack is empty, and the method to search the stack for an item and discover how far it is from the top. So this all method you have in the stack. Okay, so we will see that one by one. Only one thing you try to remember: a stack is the data structure which will help you to achieve last in first out, right? Whenever you have a requirement, where you have list of object and you want your last object should come out first, you go for a stack. Okay, you go for a stack blindly. When you have requirement where your first object should come out first, then go for queue. That's the difference. There is no other difference. See, everything implement list. Apart from that, if you have other requirement, go for array list or linked list based on your project requirement, based on the type of data, based on the operations which you are going to perform, right? So we'll focus on this stack here. There are very simple 5 methods we need to understand. One is empty. You know that name itself says that there is no data in the stack, which means it is empty. Pick method. Look at the object at the top of the stack without removing it. So again, this is like similar to remove and similar to this element. Okay, and what we have seen that in the queue. So in the queue, if you try to recollect now, so what we have seen that this method, the element and pick, these two will not remove the data from the queue. But yes, element will throw the exceptions when there is an empty queue. Pick will not throw the exceptions even though it is empty queue. It will give you null. Same thing here. In stack, pick will pick the top without removing it from the stack. whereas the pop will remove the data and it will return the object. This guy, yes, it will return the object, but it will not remove because return type is the object. E is nothing but object. Push is very simple. It will just insert the data to the stack, and the search, you can search the data in the stack. So just simple 5 method: empty, pick, pop, push, search. Name itself are self-explanatory. Apart from that, these all methods your stack has, because it implements vector. It extends vector. So whatever method, whatever implementations vector has, indirectly your stack will get all the implementation. This all we know that I have covered everything in the array list and linked list. See this last index of iterator, hash code, contains, clone, capacity, add all, remove all, retain all, right? Set size, sublist, to array, everything I have covered. So just the thing is why I have listed out here, so that you will have some idea. People will ask you in the interview, you should not say that a stack has only 5 methods. Okay, apart from that, yes, a stack has other methods also, which because it extends vector. Say that, like, since it extends vector, it has other method. Better I have captured all the method explanations here. You guys can read that. A stack, this is the method, this is the argument, this is the return type. This I copied from the Java documentations. You can read that. Again, for the pop, this is the return type, this will throw the exceptions. You can see that this guy will throw the exceptions, whereas the push, it will not throw the exceptions. Pop will throw the exceptions when a stack is empty. Okay, when a stack is empty, pick will actually look at if the stack is empty, it will throw the exceptions. Pick also will throw the exceptions here. Pick, right? Similarly, empty, it will just check for the size, return true or return false. Search, it will search, it will give you if it is found positive, if not found negative, right? So we will see that all these methods how it works, so that we will understand very well. First we'll go to the stack. So this is the class I have. What I will do, I'll write a main, just write main, control space while enter. Okay, now you just write a stack is the class, so you can just write a stack. You can see that here the stack is also present in the Java util package. Use that. I'm going to store integer, and then you just do control space bar. It will give you the options to create the reference. Choose for this, do new, and then go for a stack. Okay, now don't create like this. Look at here. Okay, stack has, if you look at here, it has only one constructor, which is the default one. So just I wanted to show you. Okay, now let's go inside the stack class. Press or control, click on stack. See, even in your system, all the source code will be downloaded, what provided by the collections framework. So when you click on control and click on stack, go inside. See, a stack extends vector. That's what I was mentioning. A stack extends vector, and see, this guy is available from JDK 1.0 itself. Now you have, I think, 13 or 14 JDK, right? This guy is available from long time. This stack has constructor, default constructor. Now since this guy stack extends vector, and when you click on vector, press control, click on vector, this guy will extend like abstract list, random, clonable, serializable, which I have shown you in the array list and linked list. Everything we have discussed, right? Like array list also will extend abstract list, then random access, then clonable, and then serializable. So you'll have everything what you have already learned, which means why I'm trying to show here is, if this guy vector will extend abstract, and if it will implement list, random access, clonable, and serializable, which means this guy will have the method which is available in everywhere. Whatever method abstract list has, whatever list has, random access has, clonable has, serializable has, vector will have the implementations of everything except than abstract list, because this is the class, this is just extending, so it will acquire the method from the abstract class, but vector should have the implementations of all these 4 interfaces. Okay, now come back. This is our stack. So as I said, we'll try to perform some operations on the empty stack. We'll see that what happens. Stack dot, so we will go the method which we have listed. We'll work specific to the stack. One will check for the empty. We'll see that what will happen. We'll check empty. Okay, this should give us true, because yes, there is no data in the stack. So yes, true, that is fine. Now we'll go for other method of the stack, which is pick. Let's see that pick what it will do. See, it is throwing exceptions. So when you try to perform pick and when the stack is empty, you will get empty stack exceptions because there is no data in the stack. So I can just, for your reference, I can print it here, and let me comment this method, because when exceptions will come, my program execution will not continue. Now pop. So what pop will do? Pop should not throw the exceptions. Okay. Oh, mind blowing. This guy also will throw the exceptions. Let me go back. Okay. Yes, this guy will also throw the exceptions. Only the difference is pick will not remove the data. It will just return the data. But if it is empty, it will throw the exceptions. Actually, that's I have just now shown you, but I forgot, my mistake, I missed. So pop, if you look at, see, this guy will throw empty stack exceptions, and pick also will throw empty stack exceptions. That's what I have written in my notes also. Okay, by mistake I told you, sorry for that. So this guy will also throw exceptions. So I can make a note here. Let me comment that. So we are done with pick and pop. Basically, when empty stack, both will throw the exceptions, right? Size, we have seen that. Now we will work on push method. Push method is very simple. It will add the data. So when you do a stack dot push, so when you push that, basically how it will add is, let's say 80, right? So let me push some data. 80, 70, 60 and 10, right? So data got added, and then finally let me print a stack. This is the output. Okay, so basically if you look at, when you are pushing the data in the stack, okay, this true came because we are printing that stack.empty. Yes, it was empty, so it came true. When you add the data, it will add the data to the stack and it will return the same object. So when you added 80, so basically what happens behind the scene, it will add like integer.value of, and you know that integer.value of return type is the object. So it will add the object and then it will return. So all your integer object is getting returned and it is getting added, and this is your stack. So data is getting added. Now on this, once the data is added, try to perform the actions and see that how it works. Okay. Now on the stack, we will try to perform some of the operations which were failing earlier. So I will do a stack dot pick. Okay, and then print the stack. Similarly, we can try stack dot pop, then print the stack, and similarly I can try stack dot index of 60. Okay, and then again I can call this method. Let's see that now what will happen, what pick will do, what pop will do. We will try to understand. So pick, as I said, it will remove the head. See here, this you leave it, this I have already explained. We will start from here. Stack dot pick. So stack dot pick basically if you look at here, you are getting output as a 10, right? Remember in the queue what was happening? Queue, your output, if this was the queue, your output should have been 80. Okay, because queue is FIFO, first in first out, but the stack is LIFO, last in first out. So the 10 was last in. When you try to fetch, this guy will come first. It's a LIFO. The stack is the LIFO, last in first out. So this guy entered last, 10 got entered last, but when you are fetching, it is coming first. But again, there is no change in the stack data. There is no change. All objects are intact. Now pick method, stack.pick. So stack.pick here, if you look at, it will fetch 10. Again, it will fetch the last in first out. Whatever was entered last object, it will fetch. So it is fetching the object, and then your object is getting removed from the stack. So now you can see that 80, 70 and 60, right? And then after this, when you try to search for index of 60, so after the operations, this is your stack. When you try to search index of 60, which is this method, this is 0 index, this is first index, and this is second index. So you are getting that second, and you are just printing that. And then you are trying to do stack.empty. So when you do stack.empty, your output will be false because it has a data. So now you understood the difference. That's how it works. See, the stack, it's a LIFO concept, right? So when you actually try to fetch the data, it will fetch last in first out. Whatever was entered last, it will be get fetched first, right? But if you go to the queue here, if I have to queue here, so if you look at the element, when we tried here, let me just run that. So you look at here, this is your queue. Okay, when you try queue.element, what object got returned? 10. This guy was entered when first, because see, this guy, this was entered first time, this was entered last time in the queue, this was entered in the first time. So in queue, when you make an element or when you make a pick call, it will pick the first object which was entered. So it's like FIFO, first in first out. And when you did this queue.element also, same got printed, there was no data removal. When you did pick also, pick what it did, it removed the first one. It's like FIFO, first in first out, and then it returned that 10 and nothing happened. Okay, when you did a pull, so pull, what happened? It again FIFO, first in first out, it will remove the 10. Now this pull will remove. This pick an element will not remove, it will just return the object, it will not remove. The pull will remove. So when pull will remove, you can see that you have 20, 100, 300. So this is FIFO concept, whereas this one stack is LIFO concept, but the queue is FIFO concept, right? So with this, we are done with stack also. Thank you guys. Thank you for watching this.